We're after getting the pH at the equivalence point in acid-base titration. So this is the second part of a two-part series, I guess. And what we're really working on is a very money-making region of chemistry. It's called analytical chemistry. And this is really kind of some of the foundation knowledge of it. And there's a lot of money to be made in analyses like what you're working on and what you're learning about. So let's start with a little bit of review. And you see the titrations. And I just want you to write a Ka or a Kb reaction. Right? The Ka or the Kb reaction, that would actually pH. It's the controlling equilibrium that determines the pH of this at the equivalence point. So take a look at it, identify what the conjugate acid or conjugate base is that's going to be dominant, and then write the corresponding Ka reaction or Kb reaction. Remember, Ka reactions are conjugate acid, conjugate base. If the Kb reaction is the conjugate base plus water gives hydroxide and the conjugate acid. Write that. Oops. You need your handout, right? It's in there. Okay, let's pick on Ray. Ray, in this part A, where'd he go? He took off. He went early spring break for him, I guess. Genevieve, did you write a Ka or a Kb reaction for this first one? Did you write a Ka or a Kb reaction? So if it's a Ka reaction, that means you have to have a conjugate acid at the equivalence point. We titrated with N. If there's any acid there, it's gone. It's all in the form of the conjugate base. Right. It's got to be a Kb reaction. What would be the K? What would Matthew? What did you write? Cn minus the conjugate base plus H2O, coolest hydroxide, and back to the conjugate acid. Good. So there's our Kb reaction. How about Destiny, the titration of hydrofluoric acid with NaOH? Did you write a Ka or a Kb reaction? Kb reaction, good. What is it? Yeah? Just forgot one thing. She forgot the minus on the fluoride. Okay. Jessica Rojas, how did you write? Did you write a Ka or a Kb reaction for C? She wrote a Ka reaction. Does everybody agree? Yeah, the Ka reaction. Hold it. Titrate methylamine with HCl. Yeah. Sorry, I'm getting lost. This methylamine I have to go backwards, otherwise my HCl definitely is a acid, a strong acid, right? So if that's an acid, that means this has to be what? Has to be a base. So if you're not sure what it is, you know, you look in the table. And you're not going to look in the table that has Kas. You're going to look in the table that has Kbs. It's a base. So you look for it in there, and you find it. And then you have to recognize, okay, I'm going to have, at equilibrium, at the equivalence point, I'm going to have the conjugate of methylamine. It's going to be an acid. Have to write a Ka reaction. Exactly. So what did you say that acid is, Sylvia? What did you say that acid is? And what's its formula? You have to write a reaction. Yeah. And have to memorize it. Find it in the table. What's methylamine? CH3NH2. So if this is CH3NH2, everybody, how can you write a conjugate acid? Add an H plus. Now, where do you want to put the H? Conventionally, that's where the organic people are going to like you to put that H on the amine. That's really where it goes. But if you put the H out front, HCH3NH, that's fine. I don't care. But technically, you're right. It goes on the amine. So we might as well just put it there. CH3NH, not a 2, but a 3. And don't forget to put a plus. So Ka reactions are the conjugate acid goes to H plus and the conjugate base. So I'll have H plus and what, everybody? Yeah. Back to where we were. All right. Okay. Here we go. Now, they have 12 grams of acetic acid dissolved in 50 mils of water, titrated with 2.8 molar NaOH. So first, at the equivalence point, what dominates? Juan, what ion or what compound would you say dominates? Is it the acetic acid or is it the acetate? The acetate. Right. Because you're titrating with Na and all that. And you start with acetic acid too. So you know it's going to all be gone. Exactly right. Okay. And what is its concentration? So, Vanessa, we've been doing this, but I want to point out something else first. Because we're going to find its concentration. And then in the big end, the big goal is what? Yeah, but I mean in the very final question, this is what all the homework is. Find the pH. Okay? And you've done this. You just have to remember a week ago. Calculate the initial concentration of acetate. Let's pretend the answer is 0.18 molar. Okay? That's the answer. And that's a homework question from last week. What's the pH of 0.18 molar acetate? Well, you have to write a K what reaction? B, because acetate is a base. You have to write a KB reaction. And then you do ice. We did ice, right? And we put that, what did I say? I made up the number 0.18. That goes in the initial row, under the acetate. We do ice. And then we get pH out of it. So that's all we're going to do. So these questions are just like last week, except they're pretty much twice the work, because you have to calculate what number to put in the initial row. And that's what we're going to do in Part A. Okay. So let's see if we can get that initial concentration of acetate. Vanessa, where did we start with this kind of thing? Yeah. Right. Yeah. I guess what I was after is give you some guidance, right? I think just trying to talk about moles or something. But I guess we could write even more here. All right? Yeah, I don't know if you hear. Okay, now what can I put on the bottom? Liters, but it might be more descriptive to write what? A little more English, not numbers yet. Yeah, liter solution, but are you going to put just 50 mils down there? No, so I'm after. You're going to have to. You're going to do whatever's given plus D. What was it? Something point, the equivalence point. So down here, descriptive, what could you use to? Because you could just write liters. But are you going to total? Are you going to remember to add the 50 plus the equivalence? I don't know. You probably will. But if you write total down there, it's a real guide, I think. And the more English you put in here in these questions, the much easier it is. Because otherwise you're wondering what to do next and why you did it. So big M of the acetate equals the moles of the acetate over the total liters. Just by acetate in total, it's really going to guide you. It really will. Trust me. Okay, now Vanessa was talking about how to get that moles of the acetate. And she's exactly right. It has to be the same as the moles of acetic acid. Now, how do you get the moles of acetic acid? Okay, now Pablo's right, but let's do it the wrong way first. This is how we did it before. Right? Big M was moles over liters, and then we solved for this one because they gave us that and they gave us that. But they didn't give us liters, they didn't give us molarity of the acetic acid. Pablo noticed it. They gave you grams. And how do you convert grams into moles? The technical word, though, it helps you. Molar mass. You got to calculate molar mass. Okay. So that's 12 grams of HC2H3O2. And just by writing HC2H3O2, it guides you what to do if you remember it's molar mass. Because right there, you wrote down everything you have to add up. Okay? I need 4 hydrogens, 2 carbons. What did you come up with? 60? Did you get 60? Okay. A whole bunch of people are getting 60. That's got to be it. Now I need 12 over 60. Should be and that should be 0.2. But I hate doing stuff in my head. Is that right? Okay. That top part's 0.2. Equals. Now we have to get the bottom, the total liters. Now for sure, what's going to be part of that liters? 0.05. Is it 0.05 or 0.5? 0.05. Move it over 3 places. Plus, what's the word? Equivalence point. Good. You got to find it. Okay. Victoria, how are we going to find the equivalence point? Now, we were doing extra work before, and I didn't catch it until today. I don't know if you noticed this. We were doing extra work. Javier, did you notice it? Yeah, we could have just used the moles in the first place. You see what he's saying? You use this. Before we started out with the milliliters, then we multiplied on concentration to get moles. Well, you could skip all that if you would have just started with the moles in the first place. 0.2 moles acetic acid. Start there in the half the writing. Right. So when we're after the equivalence point, Lewis, what could we do next? What did we do next then? Yeah, what was this called? The what bridge? Mole bridge. 1 mole of acetic acid. Oh, how am I looking away? Yeah, the mole bridge because we want to end up in liters of NaOH. Yeah, now we're ready for this. The big M of NaOH. Moles, 2.8 moles of NaOH per liter, but the moles had better go on the bottom, otherwise it's not going to. All right, so it's pretty much just 0.2 over 2.8. 0.071 something. So that goes up here. So we can get our final answer. Red. Okay. So wait. That's it. 0.2 moles all over 0.05 plus 0.071. So, what did you get? Anybody else get 1.65? Okay. That's got to be right. Okay. So this is logical and it makes sense, and you can do it, I think, pretty quickly and without frustration if you put in a lot of English in there. Don't just write numbers like I did up here. This is, bad technique or whatever. You should have numbers on this stuff, units. Okay, and then it's a lot easier to follow. Okay, so I think we're comfortable with getting this. That's what the quiz was. And 1.65 molar acetate. Now we're supposed to find the pH. So we have some nice steps here, but really, I don't think you need to follow the steps. It's just logical. We have this concentration of acetate. We have to do ice on a Ka or a Kb reaction. Kb, because acetate is a base. It's a conjugate base. So I have to write a Kb reaction. So, Pablo, what Kb reaction would you write?
Acetate.
Yeah, acetate.
H2O.
Plus H2O.
OH minus.
Gives OH minus and acetic acid. Okay. I have to do ice on this.
So whatever you got for 1.65 of those.
Javier, what do you think? What do you put in that initial row? Yeah, exactly. 1.65 for the acetate. Everything else is going to be a dash. For water, make sure you do all dashes. Otherwise, you're going to be putting an X in there and everything's going to get messed up. Pure liquids never show up in equilibrium constant expressions. The change row, Genevieve, what do we put for reactants again? Negative X, positive X for products. And then we get our equilibrium concentrations, Matteo. For acetate would be 1.65 minus X. And the rest would just, X plus nothing is X. So, at equilibrium, my acetate concentration is 1.65 minus X. Acetic acid is X. Hydroxide is X. They want to know pH. So, Destiny, let's pretend we did all this math, and we got a number for X. How do you get pH out of that? Yeah, but use the right word. It's going to come out as the concentration of OH. Oh, good. She's following it. She sees it all because she caught it. That X, did you follow her? That X is hydroxide. So you take the negative log of X, and you get the POH, exactly what she said. And then subtract from 14 to get pH. That's what we got to do. Okay. So I get started. Write the Jessica. How do you get started on this to get our X? We need the K what? KB. So how are we going to get, gotta use KB to get it. NKW, exactly. Because you can't look up a KB for acetate. So 1 times 10 to... Now, we better hope this number is what? Really big or really small?
Really small.
Really small. Excellent. The Ka is?
No, I mean, the B. 1.7.
Thank you, sir. 1.7 times 10 negative 5, if you look it up. And
I got you.
okay, so what did you come up with, Adrian?
5.88 times 10 to the negative.
Okay, is that a number that you like to see? Most definitely. Because that's going to equal what over what? Yeah. Well, technically 1.65 minus x, but then we can drop the x. So we can get our x. Sure. Yeah, somewhere around 3.1, 10 negative 5. Realize that's your hydroxide concentration. POH, and then you can get pH. .51. And then you know that 14 is pH plus POH. Finally, like 9.5, 9.49 or so. 9.49. Okay. So let's not pretend. Let's look forward to you're doing all your homework. You just nailed all this. It's on the exam. You flew through it in a couple minutes. You got this answer. There's 10 minutes left. You can look at that answer. You can say, oh, that makes sense. Does this answer make sense? It's a base and it's above 7. Exactly. So it makes sense. Okay. If it doesn't, you can go back and see what you did wrong. Okay. So here's a couple of them. The first one has the numerical answer. See if you can get it to work. The first one, 35 mils of 0.28 molar methylamine is titrated with HCl. Now, you've already been given that. You already figured out the reaction at the equivalence point, the dominating equilibrium. Identify what the conjugate acid or base is that's being formed, and calculate its concentration. That's what you'll use in the ice table. you're not sure where to go, fast. Write a lot of English, too. A lot of little descriptors. Formulas, total volume. Now to start out though, methylamine is titrated with an HCl. So that means that methylamine must be a base. So you're going to end up with its conjugate acid. So it's back in earlier in the notes. We wrote, I think, CH3NH3 plus gives H plus methylamine. It's going to be a Ka reaction, not a Kb reaction. At the equivalence point. Have to do ice of the K. You solve for x. So you have to multiply both sides by 1.65 and then take the square root. Because this equals x squared over 1.65. Yeah, you have that reaction. Well, yeah, here's the reaction right there. You're going to end up doing ice on this. But you got to calculate the initial concentration. Moles over total volume. Let's make sure everyone's on the same page here. So. All right, so you gotta, this is what you're gonna end up doing. You have to calculate that initial concentration. Ten to the negative 11, yeah. So remember, anything smaller than 10 to the negative 5. What are you guys getting for your initial concentration? Javier got 0.12. Okay. I bet you need to get this right here is going to be 0.12. If you don't get that as your initial concentration, you messed up somewhere. That number looks awfully big, 1.23. Whoa, why 0.28? It's this. This is the moles, right? And see where you messed up? You didn't write. If you would have wrote, right? It's this. You cut. That is going to cancel down here, right? Actually, it's NH3 plus. Oh no. This is fine. Because this is the same as the moles of NH3+. So that's fine. So you can start with that.
So that's
That goes down here. And that's the only place you messed up. Okay, you have to get the moles of the conjugate acid divided by the total volume. And that's how you come up with the 0.12.
Yeah, divide that by 0.35?
Plus the equivalence point. Yeah, the answer should be 5.8. There's another one down there that you can try.
Trying to get the liters for the...
Now this part, I think get this.
Oh, I got it wrong. I did something else, but it's supposed to be that.
All right, so
I did 0.28 of the...
Well, yeah, but that's not the moles of the stuff. That's the moles per liter. So you take this times the number of liters, and you'll have moles.
Oh, okay, see, that's what I got. See, I did 0.28 times point...
Times 0.035.
Oh, okay.
And that would be 9.8 times 10 negative, or 0.0098, and that goes up on top.
Oh, okay, so that's what goes right here?
That's what goes up on top. 0.0098.
0.0098.
98. And then
0.35 plus?
0.035. We're over 3 places to convert no
You still need to let something else.
You owe the equivalence point because you added all this stuff and you added all this HCl. So you screwed up the volume. This is bigger than 35 mils now.
Okay.
So you start with this
0.098
and convert that all the way to liters of HCl, and that's what you add in there.
Start with 0.098, right?
Yeah, moles of the moles of the stuff. And then the mole bridge is 1 to 1. Now, if you got the answer, there's another one down there. Go ahead and try it. That's good. The more English you write, the easier it will be for you to follow in a month, and that's when you take the test. Choose it to work. Moles, and now it's in liters. And whatever number you get here, that's what you should add in, because that's the volume of the HCl you added. 0.28.
0.28 HCl? Or is it HCl?
Oh, sorry, that's a 1. 0.21. 0.21. 0.47. Yeah, that's... And then you'll have your initial concentration. And hopefully you get 0.12. Did you guys get the 0.12 for the initial concentration? Did you get to what? You get the 0.12? Okay, so moles. So the moles would be, the moles per liter, multiply times the number of liters, and you'll have the moles. Or do the equation like you have here. So that times 0.28. Yeah, 9 point. That's only moles though. So you have to divide that by the total volume. So 0.098 divided by the total volume. 035 plus the equivalence point, and you start here. A few more minutes. Make sure you know what you're doing. Did you get the 0.12? Okay, you got the total mole, this is the mole over the total volume, 0.035 plus. So you started here, good. Moles of that stuff. This should work. Well, what did you get for liters? 0.047? So that's the extra volume. That would go in right here, 0.047. That should be 0.035. Yeah. So 0.0098 divided by those two, you should get 0.12. Did you get it to work? Okay. You got the 0.12? Okay. Oh, okay. There you go, yep. We're about out of time, but come by and glad to work with you on any of these. Make sure they make sense.